Ever wonder how AI can see and understand images without being told exactly what to look for? Today, we're diving into a game-changing method called DIP that's rewriting the rules of how machines learn to see. Let's start with the problem. Traditional AI models need tons of labeled data, like thousands of photos tagged cat or dog, to learn. But what if we could teach them without all that human effort? That's where DIP comes in. It's part of a new wave of techniques using unsupervised learning, where AI figures things out on its own. Here's the trick. DIP builds on a model called DINOv2R, which already has a strong foundation in understanding images. But instead of relying on human-labeled data, DIP creates its own training tasks. Think of it like giving a student practice problems to solve without the teacher's answers. These pseudo-tasks are generated using a tool called DiffCut, which automatically splits images into meaningful parts, like identifying a car's wheels or a tree's trunk. The model then learns to recognize these parts without any human input. Now, why does this matter? Let's look at the results. In tests on datasets like PascalVOC and ADE20K, DIP outperformed existing methods like NeCo and even DINOv2R itself. The improvements were biggest when there was very little training data, what's called a low-shot scenario. For example, on PascalVOC, DIP boosted performance by over 2% compared to its predecessors. And on a depth prediction task, think 3D structure of scenes, DIP even beat models specifically designed for that job. But here's the kicker, DIP's approach is efficient. Training on a single GPU took just 17 hours, depending on the model size. That's a fraction of the time and cost of traditional methods. Plus, it works across different image types, from cityscapes to snowy roads, showing it's not just good at one task but adaptable. So what's the takeaway? DIP proves that AI can learn to understand the world more like humans do, by exploring and practicing on its own. This could revolutionize fields from self-driving cars to medical imaging, where labeled data is scarce. And as researchers keep refining these techniques, we're one step closer to machines that truly see the world. Ever wonder how your phone recognizes faces in photos or how self-driving cars see the world? Traditional AI models rely on a huge problem. They need millions of images labeled by humans, every pixel tagged as grass, car, or person. It's like asking a toddler to sort a million puzzle pieces by color, one by one. Tedious, right? But what if we could teach computers to learn without all that manual work? That's where self-supervised learning steps in. Think of it as letting the AI solve its own puzzles. Instead of being told this is a cat, the model might guess, what's missing in this corner of the image? Or which parts of this photo look similar? It's like teaching a kid to recognize shapes by asking, what comes next? Instead of naming every shape, the AI figures out patterns on its own, no labels required. Here's the clever twist. The researchers used pseudo-labels. Basically, the AI generates its own guesses about what's in a photo. These aren't perfect, but they're good enough to keep learning. Imagine a student taking notes during a lecture. The notes aren't flawless, but they help them study smarter. The AI uses these rough labels to refine its understanding, getting better with each round. The team tested this approach on massive datasets like COCO and PascalVOC. Think of them as giant photo libraries with millions of images. Their method, called DIP, smashed previous records. On COCO, it nailed 86.7% accuracy in identifying objects, 2 points better than earlier models. In AI terms, that's like breaking a long-standing world record. So how did they do it? They didn't retrain the whole model. Instead, they tweaked just the last part of a pre-trained vision transformer, a type of AI inspired by how our brains process visuals. They also used a trick called nearest neighbors, where the AI compares images to find similar ones, like asking, which of these photos looks most like this one? To sharpen its guesses. And here's the best part. The pseudo-labeling process, while intense, it took 17 hours on a single GPU, only needs to happen once. Those labels can then train multiple models, saving time and resources. It's like creating a master key that opens many doors. Why does this matter? Well, imagine AI learning from the billions of unlabeled photos we upload daily. Social media, surveillance cameras, even your vacation snaps. This could lead to smarter medical tools that spot diseases in scans, or self-driving cars that understand complex street scenes in real time. Want to know how DIP compares to other models, or what's next for this tech? Hit subscribe, and let's keep exploring the future of AI together.